Welcome back, everybody, for another deep dive. This time we're looking at AI and math. Specifically, how machine learning is making what are called SMT solvers even smarter. Think of them like the ultimate Sudoku masters, except they work on way more complex math problems that have real impacts like in software and engineering.
Right. SMT solvers are great at crunching numbers and logic puzzles, but they really struggle when it comes to something called quantifiers.
Quantifiers.
Yeah, these are little words like for all or there exists that can really throw a wrench in the works because suddenly you're dealing with uncertainty and like infinite possibilities.
So it's like trying to solve a Sudoku, except some of the numbers are actually variables, and the rules are all like, for all x, this must be true.
Yeah.
So suddenly the puzzle is way more complex.
Exactly. And traditional SMT solvers, they try to deal with this using like instantiation, which is basically trying to guess the right values for those variables. But this can be super inefficient.
So where does machine learning come in? Today's deep dive is based on research from the Czech Technical University and others, presented at the European Conference on Artificial Intelligence just this year.
The researchers found a pretty clever way to use machine learning to guide these solvers. Essentially, they trained an AI to predict which quantifiers are actually worth instantiating. It's like giving the solver a sixth sense, helping it avoid wasting time and focus on the paths that will actually lead to a solution.
That's awesome. But how do you even teach an AI to understand these complex math problems?
Well, the researchers use something called a bag of words approach.
Bag of words.
It basically creates a fingerprint of each mathematical formula based on the symbols it contains.
So instead of words, they're looking at all the plus and minus signs and all that.
Yeah, exactly. It's like if you were trying to understand a sentence just by counting how many times each word appears, it gives the AI a way to recognize patterns in the math language.
Clever. To really learn, though, this AI must needed a ton of training data. Where do you even find enough math problems to keep an AI busy?
They used the Mizar Mathematical Library, a massive online collection of formalized mathematical knowledge. It's like the ultimate math textbook for an AI.
Wow, so they basically gave this AI a PhD in math, and I'm guessing, based on the results of this research, it passed with flying colors.
The results are pretty remarkable. Adding this AI guidance resulted in a 21.4% improvement over the current state-of-the-art SMT solver portfolio. That means it solved way more problems in the same amount of time.
Wait, a 21.4% improvement? That's huge. We're talking about going from like a snail's pace to a brisk walk when it comes to solving these math problems.
And these aren't just obscure math problems either. Remember, SMT solvers are used everywhere, from verifying the software on your phone to designing safer airplanes and making power grids more efficient.
Okay, yeah, now I'm really starting to see the potential here. A 21.4% improvement in efficiency could have ripple effects across tons of industries.
For sure. What's really fascinating, though, is that this AI guidance wasn't limited to just one solving strategy. The AI could actually learn from the data of one strategy and then improve the performance of a totally different strategy.
So it's not just memorizing specific moves, it's learning something fundamental about these problems and how to solve them.
Exactly. It's called cross-strategy transfer, and it suggests that the AI is picking up on something deep about quantifiers regardless of the specific techniques being used.
That's amazing, like learning jazz piano and suddenly you're better at classical piano too.
I like that analogy. It hints at the broader possibilities here. We might be at the start of a whole new era where AI can help us solve all sorts of complex problems, not just in math. But before we get too ahead of ourselves, let's look a bit closer at how they actually built and trained this machine learning model, because there are some interesting things going on there.
Okay, let's unpack this AI's bag of tricks. I'm ready to get technical. Okay, so we've talked about this bag of words thing. The AI is analyzing the formulas based on the symbols in them, right? But how does it go from there to actually learning which quantifiers are important?
Well, that's where the real magic of machine learning comes in. They didn't tell the AI which quantifiers are good or bad. They let the AI figure it out by itself from data.
Data. It always comes back to that, doesn't it? So what kind of data did they use?
They basically ran the SMT solver on a bunch of problems from that Mizar mathematical library we talked about. And as the solver worked, they kept track of which quantifier choices actually led to a solution.
So it's like they're showing the AI a bunch of solved Sudoku puzzles and saying, see, these moves worked, these moves got you to the answer.
Exactly. And of course, they also recorded the quantifier choices that didn't help, so the AI could learn to tell the difference between good moves and bad moves. Kind of like how a chess AI learns.
Oh, speaking of chess, you mentioned before that this AI could actually improve different solving strategies, right?
Mhm.
That still blows my mind. It seems like it's learning something universal about these quantifiers.
Right. That's what's so cool about this research. They actually trained the AI on data from 3 different solving strategies. So it's like learning the underlying principles of chess, not just one specific opening move. And the results showed that this knowledge could then be applied to make other strategies better, even ones it hadn't seen before.
That's wild. So how do they actually make this AI guidance work with the SMT solver? Do they have to rewrite the whole thing?
That's the best part. They didn't touch the core code of the solver. The AI is like a separate module, like an advisor. It analyzes the problem and suggests which quantifiers are worth looking at, but the solver ultimately makes the final call.
Like a mentor whispering, "Jeez, hey, I think this path looks promising."
Haha, yeah. And to keep things interesting, they even added a bit of randomness, so the solver wouldn't always just listen to the AI. Even if the AI thought a certain quantifier was a bad idea, there was a small chance the solver would try it anyway, just in
So
case.
they're hedging their bets, making sure the solver doesn't get too reliant on the AI. It's a nice balance between the AI's guidance and the solver's own logic.
Absolutely. It's all about finding that synergy between human-made algorithms and the learning power of AI, and about that 21.4% improvement. Well, that's not even the whole story.
There's more. Tell me everything.
Okay, so the model actually struggled with problems that had been pre-processed using something called skolomization.
Oh, that sounds complicated. Break it down for me.
It is a bit technical. It's a way to simplify logical formulas by basically replacing some quantifiers with new functions. Think of it like shortening a sentence by using pronouns. Sometimes it works well, sometimes it makes things less clear.
So it's like they were giving the AI a slightly different version of the math problem, and that messed it up?
Exactly. This finding suggests that this skolomization thing might actually be hiding information that the AI was using to make its predictions.
Interesting. So it's a reminder that we need to be careful about how we prepare data for AI.
Yeah.
We can't just assume that any simplification will help.
Right. It highlights how important it is to understand how AI learns and how different techniques can impact that process.
It's a good reminder that AI is still a tool, and we need to use it thoughtfully, not just blindly throw data at it and hope for the best. We need to be aware of its limitations and potential biases in the data, too.
For sure. As we build more powerful AI, we need to prioritize transparency and fairness, make sure it's used for good, and that we're always checking its impact and making changes as needed.
Well said. So we've seen how these SMT solvers work, how AI can guide them, and the incredible potential that has. Our listeners should have a much better grasp of all of this now.
I hope so. It really shows how advances in one field can lead to breakthroughs in others, and that we're always pushing the boundaries of what's possible. There's still so much more to discover.
Yeah, it really is amazing to think that something like improving a math solver could have such a big impact on things we use every day.
It shows how everything's connected,
Yeah.
Like advances in one area can lead to breakthroughs somewhere else. And that's what I find so exciting about this. We're always pushing the limits, and there's still so much more to learn.
It's like we're explorers charting new territory, and AI is like our compass or our map or something. But you mentioned that this AI actually had trouble with problems that had been changed using that skolomization technique, right? Why would that be?
Hmm, that's a good question. And honestly, researchers are still trying to figure that out. One possibility is that even though skolomization is supposed to make the problem simpler, it might actually be removing information that the AI needs to make its decisions.
Oh, I see. So it's like giving the AI blurry glasses. It can't see the details it needs.
Yeah, exactly. It shows how sensitive AI systems are to the way we give them data. It's not just about giving them as much data as possible, it's about understanding how different techniques can affect how they learn.
It's a good reminder that AI is a tool. And like any tool, it has to be used carefully, right? We can't just throw data at it and expect it to work perfectly. We have to be aware of its weaknesses and also think about any bias in the data we use.
Absolutely. As AI gets more and more powerful, it's so important to be transparent and fair. We need to make sure that AI is used to benefit everyone, and we need to be constantly checking how it's being used and making changes if we need to.
Really important points. So in this deep dive, we've seen how these SMT solvers work. We've explored the possibilities of using AI to help them solve problems, and we've talked about the potential impact this could have. Hopefully everyone listening has a better idea of how these things work and why they matter.
I hope so too. It's been a really interesting discussion. It's important to stay curious and keep learning about AI. You never know what amazing discoveries are just around the corner.
Well, that's all the time we have for today. Thanks for joining us for this deep dive into the world of AI and SMT solvers. Until next time, keep those brains buzzing.